So now we have to calculate this integral here. So we can bring this, the v0 square over a square, outside of the integral. So that should be v0 square over a square. And now, how we'll solve this integral? I mean, we can solve it by substituting whatever, let's say, tan theta equal with, let's say, z. So from that you will have the dz over dz over d theta. That should be equal with sec square theta. And now if you go back to this integral here, what it will be, we have 1 plus, we said whatever tan you put z, so that should be 1 plus z square. And here if you solve for d theta, because we have to substitute this d theta here, if you solve for d theta, you will have that d theta, it will be equal with dz over sec square theta. And of course, we have the sec square theta here. This here is in brackets. So this cancels with this. And we are very beautiful now, because I mean, the integral now of this with respect to z is equal with the integral of this is z plus z to the third over 3. We still didn't put the limits of the integral. We'll put it in a minute. And now what we have, I mean, we said that z was equal with tan theta, so let's go and substitute whatever z equal with tan theta. So what will be, it will be v0 square over a square, and here we will have we said whatever z we substitute tan theta, so that means we will have inside tan theta plus tan theta to the third over 3. The initial substitution was y is equal with v0 square over a. So that means it was y is equal with v0 square over a times the tan theta. So from that we have that tan theta is equal with y a over v0 square. So now we can go and substitute it back here, and we have v0 square over a square times y ya over v0 square plus ya to the third over 3 v0 to the sixth. Excellent. So, and of course now we have to integrate this from we said from 0 is the lower limit, is 0, and the upper limit it's this here y. The y was v0 times square root of 2d over a. So, and because that's, if we assume that this is 0 and this is the negative direction, so this is this value here, let's call it y1. So, and now if you substitute whatever in this equation here, if you substitute whatever y1 and 0, whatever y you substitute y1 and 0, you will get the final answer, which it will be the only unknown. It will be v0, because the rest is given. That d is given, a is given, because all e capital and the mass of the proton is given. So the only unknown, it will be the v0. So, and of course this is equal with something that we know, we said is s, which is given. So if you solve this equation, you will be able to find v0, the initial velocity of the proton. So again, I know the math was like more complicated than the physics, but the main reason that I turned this on YouTube, it was of the fact that this S here